Hello everyone. Today I'm going to be showing you some basics for making assemblies in SolidWorks. The parts I'm going to be using are for my office chair modeling project. First, I'm going to create an assembly for the wheels of the chair. I'm choosing to make this a sub-assembly because it is a clearly defined set of parts separate from the rest of the model. Also, I will be repeating it 5 times in the full chair assembly, so it is easier to deal with the set of parts one time and then just reuse the sub-assembly from there. After creating the assembly file and saving it, I'm going to insert the 4 components I need by clicking on Insert Components and then browsing for the files. So, I have 3 files, the wheel, wheel bracket, and wheel axle in this folder. I'm just going to open those and drop them in, just anywhere really. Then, I'm going to go back to Insert Components and find my 4th part on the desktop. There we are. And I'm just going to rotate that. There we go. Now I'm going to choose one of my parts to be my base part. SolidWorks automatically makes it the first part that you place, in this case the wheel. But I don't want it to be the wheel, I want it to be the ball bearing. So what I'm going to do is make this wheel float instead of fix. And you see the F is no longer in front of that part's name. Then I'm going to choose the ball bearing, and I'm going to, rather than just fixing it in whatever location it is, I'm going to expand the part and select its origin. Then I'm going to control click the origin for the entire assembly, and I'm going to mate those together. And that will align the part with the assembly file so that everything is nice and centered. Now I'm going to accept this, and from there I'm going to have to move all of my parts to line up with the ball bearing. Another way you could do it is just drop the ball bearing in first, and then when you drop in the components after that, you'll have the rotation marks down there that you can use to line them up. So now we're going to work off of the ball bearing because that is set geometry. I'm going to move all these parts out of the way for a minute and attach the wheel bracket to the ball bearing. And to do that, I'm going to select the bottom face of this ball bearing, and you'll see I'm already in the mate menu. If not, then just click the mate button up here. So now you see that face is selected, and I want to make it coincident with this face of the wheel bracket. And you'll see the wheel bracket will move to align. So we can accept that using the check mark there. Now I'm going to align the holes of these 2 parts by just clicking on the inside there of that cylinder and the inside of that cylinder, and that will line them up. Click check mark. There are 3 check marks, the one I just clicked, the one on the left, and then the one in the upper right. And now, because I aligned the hole and I aligned those 2 flat surfaces, but I haven't aligned anything in the 3rd axis, this can rotate freely just like the wheel bracket should. Now I'm going to insert the pin into the hole in the wheel bracket. So to do that, I'm first going to make the circles concentric, like so. Then I'm going to select this inside face of the pin head and mate it to the outside face of the wheel bracket. And that will make them line up nice. And you can see this is a very tight fit, so the pin is not going to be moving anywhere. Next, moving down our line of parts here is our wheel. Now I'm going to do the same thing I just did to the wheel and the axle. Make those concentric circles. And now here is where we start using some more complex mates. We're going to go down to the Advanced Mates tab, and here you're going to see this button is a limit distance. So we can set a maximum and minimum distance that this thing can move in, and that will allow for more freedom of motion between parts. So I'm going to have the wheel be able to move on the axle anywhere between the two sides of the bracket. So I selected the wheel, and now I'm going to select the side of the bracket, and now I'm going to limit the distance. First of all, we're going to switch to millimeters because I keep forgetting to do that. Okay, back into mates. I'm going to go back to Advanced Mates, select Limit Distance, select the two faces that I want to put this mate on, and you see they kind of move together, but I don't want them that close. I want the smallest distance they are from each other to be 2 millimeters, and the farthest distance they are from each other to be 6 millimeters. And you'll see it aligns to get inside of that range there. And we're going to accept this. And now you see the wheel can move anywhere on that range of the axle. And also the bracket still pivots. So now this is functioning just like the whole wheel kind of sub-assembly there works. So we're going to, now that we're done, close out of the mates. And we're going to save this. Rebuild and save to make sure that everything is nice and good. And there you go. This is ready to go into another assembly. Okay, so now I've created a new assembly. This will be for the chair suspension. And I've inserted all of the components we're going to be using already, including the sub-assembly we just made with the wheels. That I did that to save some time. And quick tip before we get started on all the mates, if you are ever working on an assembly and you get like really zoomed out or like turned around, or you just somehow lose the part entirely, you can just press the F key by default and it'll zoom you right back into the parts you're working on. So I'm just going to go isometric here, be consistent, and to start we are going to select the main height rod, and this is the part that I want to set as my origin piece. So I'm going to select the origin of the part, select the origin of the assembly, and mate them. Make sure that the axes are aligned, and hit that check mark. Next, I'm going to get the hard part of this assembly over with, and that will be getting this height adjustment cup to line up with the threads on the height adjustment rod. So I'm going to first select the outer diameter of the cup and the rod and get those to line up concentrically. Select the check mark. Now I'm going to do a limit distance like I did in the previous assembly. So I'm going to select the top of the cup, the bottom of the rod, and go to Advanced Mates, go to Limit Distance, and I want the distance between there and there to be somewhere between 105 millimeters at the minimum and 235 millimeters at the maximum. Going to allow that, and now you can see that this won't go any lower than the threads in there. It'll go as low as it could in reality, and it'll go as high as it could in reality. Okay, now for the fun part. We get to go back to the previous mate we made. That was the concentric mate. You do that by opening this drop down for mates, select the concentric. There we go, edit feature. And we're going to change this from a concentric mate, which I had just done to get that limit distance set, we're going to go down to mechanical mates and select screw. And this is going to allow us to set a screwing mechanical motion that has to be completed when you want to adjust this piece. So I know that the measurement is 1 millimeter traveled for each revolution of the cup that you make. So I'm going to set it up like so, and then check that off. So now, if you want to move this part up, you have to rotate it. You can see it slowly moving up. And this is how the real chair is, and it's almost a bit annoying trying to get to adjust the height because it takes forever. But anyway, moving on from that, next step is to get the height adjustment rod to sit inside the legs here. So I'm going to select that outer diameter, select the inner diameter of this hole here, and I'm going to mate those concentrically. There we go. Now I need to adjust the height, and the height of the chair is simply adjusted by that height adjustment cup sits by gravity on the legs. So I select the top face of the legs, I select the bottom inner face of the height adjustment cup, and they sit together quite nicely. So now when I move the adjustment cup up or down, the legs move with it, and the adjustment cup automatically turns if you just grab the legs like I just did. Okay, so we've gotten pretty far already. Now continuing, we have our assemblies from before. I'm going to attach those to the legs. So I'm going to start by selecting the hole in the leg and lining up with a hole in any one of these little assemblies. There it goes. Check that. And now I'm going to make the top and bottom faces coincident so that it meshes nicely together. And there we go. That is one of the 5 sub-assemblies attached. Just gonna do that 4 more times real quick. We'll see how real quick is. That's 2. I'm actually going to trim out these next 3 here. And here, just finishing the last coincident mate. There we go. So that took a little bit of time, but it wasn't too bad. Now, if we hadn't done the sub-assemblies for each of those wheel sets, and we had just done the separate parts 5 times over inside of this whole assembly here, it would have taken a very long time. So the sub-assembly can really be helpful, especially when you get onto larger and larger projects. So now we have those attached, and they kind of move around, but the wheel won't actually rotate on the axle, and the ball bearing is not a free part on the bracket. It's only rotating with respect to the chair, the rest of the chair. So in order to fix that, I'm going to go to each of the wheels, and I'm going to click on this Make Subassembly Flexible button. And you might not be able to see it really in this model, but now the wheel will rotate, and everything inside that subassembly is able to just move by itself now. And I'm going to do that for each of these wheel sets. One more. There we go. Okay, now they all can move nice and freely, and they can all just kind of point their own merry way if they want. They don't care. Yeah. So what I did on the full assembly for this chair is, rather than just have them like all aimlessly point somewhere, unlike the real life chair, I threw a mate down on each of these wheel brackets to kind of get them to face in the right direction, or the same direction as each of the other ones. And this will just kind of make the chair look like it has some purpose in life and isn't floating in space. Because in reality, when you're rolling around in a chair, all the wheels should be facing in the same direction. If they aren't, then it's jammed or broken or something. So now it looks a lot more like how it actually operates. And this makes up the sub-assembly for the bottom half of my chair. The sub-assembly for the top half of my chair is a bit more complex. It has moving parts that allow for the chair to rock back with a spring inside. And also the seat is ergonomically shaped, so that made it really fun to mate everything together because there were curves everywhere. But yeah, this is it.